This unit is talking about quadratic functions. So quadratic functions are generally talking about ones that are in the form a x subtract p squared add q. I changed that slightly just to help connect to the pre-calc courses. And I just changed a p to an h and the q to a k. This way everything stays in one type of formatting. We'll talk about vertexes, intercepts, domain and range, axis symmetry, a whole bunch of our indicators. Of course, talking about whether quadratic functions have 0, 1, or 2 x-intercepts, writing things in their factored forms, and going through more. So in order to demonstrate mastery, you have to be able to explain the relationship between roots, zeros, x-intercepts, explain domain and range, explain number of possible x-intercepts, explain the effects of the A, P, and Q. Again, I call them H and K. And solving situational questions. So in our first section, we're going to talk about the general characteristics of quadratic functions. So first, what is a quadratic function? Well, it's a function that can be written in the standard form y equals ax squared plus bx plus c, where the a does not equal 0. Generally, basic rule of thumb is a quadratic something that has an x squared. Now it also can only have a highest power of x squared, and all of our all of our exponents have to be whole numbers. So some examples would be negative 4x squared at 2x at 1, and 3x squared subtract 1. This one doesn't have an x, but it does have the x squared. It still makes it a quadratic. Now we make a connection, we talk about it in Foundations 10 very shortly. It's just the shape is known as a parabola. So there is a lot of connections in this unit that talk about the parabolas that are connected in pre-calc 20. The only difference between pre-calc 20 and Foundations 20 is pre-calc 20 I deal with a lot of the equations first, and then we talk about the graphs. In Foundations, we're going to kind of mismatch and do everything together. So first things first, characteristics. The first characteristic that we'll talk about is the y-intercept. That is the point which a graph crosses the y-axis. Just like a line, the y-intercept is where it crosses the y-axis. This is also the point where the x equals 0. So parabola is like this. It is a continuous function, continues either vertically or vertically, it continues horizontally. This one is an upward facing parabola. Actually, that directly connects to this one. If I draw that almost the exact same parabola, this one's opening up because it's going up. Whereas if I were to draw it right here, or I'd draw the exact same type, this one's going down. But of course, I didn't finish talking about my y-intercept. Again, my y-intercept is where it's crossing the y-axis. So this one would be y equals approximately 4. And this one, we'll say it's y equals 3. That does not mean that your y-intercept is always positive. It could, of course, be moved down and be down there. So the vertex. The vertex is the point at which a quadratic function reaches its maximum or its minimum. This could also be called the turning point. It's the turning of which it changes from going down to going up. Now, I know that my parabolas here are not perfect. When we go into the sketching of them, I'll be able to sketch them a lot more accurately. Again, the vertex is the point at which it reaches its maximum or its minimum. Draw a nice parabola there. The vertex is identified as its maximum or minimum. Now in this case, this one would be a minimum, because it is the lowest point of this parabola. The point is 3, -1. This one is a maximum. Now on this one, it looks like it's about 4.5, 5.5. You can have fractional or decimal vertexes. This one, of course, will be a maximum. I don't typically ask whether they're maximums or minimums, but you should know whether it is one minimum. If it's an upward facing parabola, of course it's going to have a minimum because its lowest point would be that vertex. Whereas if you have a downward facing parabola, it would have to have a maximum because it's going down, and therefore it would have to have a maximum. And it could be called a turning point because you can see here it's going this parabola, even though it starts way up here, as we go left to right, it's going down, 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 and then from that vertex it changes to going up. Just like this one, going from left to right, it's going up at that vertex, and then it changes to be going down. How about an x-intercept? Well, hopefully we remember what our x-intercepts are, just like we talked about in Foundation of Pre-Calculus 10. See, that's a downward one, and that's an upward facing one. So our x-intercepts point to where the quadratic function crosses the x-axis. It's also where y equals 0. So in this one, we have one x-intercept of -5. This one, we'll probably say it's about 6.4. But those are x-intercepts. This one, there are no x-intercepts. There are none. Whereas I could deal with the exact same type of parabola, still an upward facing parabola. I'll slightly adjust that. And there we go. There is one x-intercept at x equals 5. Okay, an axis of symmetry. The line that separates a 2D figure into two identical parts. For quadratic functions, it's always a vertical line. So if I draw my parabola, try and make it as symmetrical as possible. The axis of symmetry is an imaginary line. It's a vertical line that would split this parabola directly in half. Now I'll try and adjust it slightly over just to make it a little bit nicer. Vertex doesn't necessarily matter too much, but this is the line that we're talking about. It's a vertical line. And it's a vertical line in this one of x equals 2. So since x equals 2, that is the line, the axis of symmetry that would cut this parabola directly in half. This side should be identical to this side. Even if I were a really wide parabola. Try to draw that really nice and carefully. Again, it's a vertical line that would cut it in half. And this one, maybe x equals -4. And last but not least is our domain and range. Always a fun one. Let's deal with an upward facing parabola here. And we'll go with a downward facing parabola here. Adjust it slightly just to make everything nice. Alrighty. So the good thing is domain talks about the x values. So our domain is our x values. Now in this case, because this arrow means it's going left and this arrow means it's going right, it's actually talking about all x values, which means x is an element of the real numbers. If we talk about our range, well, it's only hitting our y values that are from this point and up, which means our y values are greater than or equal to -6. Of course, y still being an element of the real numbers, because it's a nice solid line. On this one, again, domain talks about the x values. This arrow means it's going left, and this arrow means it's going right. Our domain of every single quadratic is an element of the real numbers. Our range, in this one, we talk about our y values. So our y values are all the ones that are less than, because these arrows also are going straight down. Our vertex here really tells us exactly what our range will be. Since going down, that y value is -6 as well. But it's only the y values that are less than or equal to -6. And those are our characteristics. Talk about a y-intercept, a direction of opening, vertex, x-intercept, axis symmetry, and the domain and range. I do want you to do all of your stuff. So just determine those same characteristics, and you'll be able to tell them. Have fun.